Right, this is the video for Key Stage 3 Systems and Control, all of you people doing the energy saving lighting project. So I've got a range of stuff here in front of me on the board which is going to be useful. Some things about connections and how we can do physical computing by fixing things onto the microbit, and the easiest way to do that. Some other ideas for kind of inputs and stuff like that. And I'm going to do a bit of unboxing for you because I'm quite excited here. I've got a V2 microbit that I've managed to buy off eBay, £6.50. I got that for a really good price. So keep looking. You might find, if you're into microbit, you might find a bargain. That's definitely a bargain, right? Okay, so pop that to one side for a second, right? This is my old system for connecting bits to the microbit board, right? And this system basically used a junction block, which an electrician would use to fix things together, but you'd get the junction block and you'd cut a slot into it with a junior hacksaw so that that would fit over the circuit board, and then carefully put it over the junction you wanted to go onto and tighten it down. Okay, it kind of works fairly well. It does tend to, if you tighten it up, you can damage the board on the microbit there, but you have to be careful with it, right? But I've got a better way I do that now. So anyway, just let's leave those on like they are connected for a second. I don't know if you can read what it says there. So one of them says RC send and the other one says RC get. So this microbit work in a pair, and I can use low energy Bluetooth to send a message from this one to this one. So if my microbit was connected on that one and it had power connection going to it, so some batteries, and if this one was connected as well to batteries, if I pressed a button I could make the LED turn on, press another button to make it turn off, or press the same button if you want to make it turn off. That's quite a cool little trick to do. Or maybe hold your finger on it to make it go dimmer and eventually off. Hold your finger on it to make it go brighter, eventually full brightness. So, you know, all those things are doable using radio control, using Bluetooth. So you'll find Bluetooth commands in the middle library, just in the standard library on Microbit. And if you want to have a mess around with them, I think that's a great idea. Okay, let's have a look at some of the other bits then before I go on about connecting physical outputs onto your Microbit, right? Different ideas for turning on the device that you're trying to control. So this is a very simple cardboard pressure switch, right? All it uses is some strips of silver foil, very flatly stuck down with Pritt stick onto the board, look, with a gap in between the two pieces, and I've stapled the wires that I've got here onto each of the tracks, and I've put a little bit of hot glue gun over the top of them as well, just to hold them really secure. And I've made this little window. It's actually made of an old post-it note, and then a rectangle square of aluminium there. So look, you can see what happens is when I close that up, the big piece of aluminium bridges the two pieces here and joins the switch. Now that only needs to happen for a second to send an input message down these wires into your microbit to say that something has happened. So that could be a very simple way of making a switch to turn a lamp on. You put that under a seat maybe, somebody's pressure goes onto it, turns the light on and waits a certain amount of time. So there's a little pressure mount sensor. What else have I got here sensor wise? Okay, this is a pretty cool one. Not the easiest one to set up on Microbit, right? But that's an ultrasonic rangefinder, a bit like a parking sensor on a car. And what that does is one of these sends a signal and one of them receives an echo from the signal. So this fires out and then hits something, bounces back, and this one receives it. And the delay in between the two signals is calculated in the Microbit program that you write, and it's given to you as a signal to play around with. You want to just put numbers on your Microbit and have try and calibrate it of a distance away from something. You can do that. You might want to have warning lights or a noise that it makes or something like that. That would be pretty cool. I tell you what, I've seen a really good project. This is a rumble pack motor out of a game controller. So it's like a motor with a weight on it that's going to vibrate as it rotates. So I've seen a really good project which is a walking stick for a visually impaired person, where this is at the end of a long pole and Microbit at the top with a motor driver circuit to the rumble pack, and as this gets pointed at an object, it sends haptic feedback to the vibration to the person holding the stick. It's a nice little project idea, isn't it? So that's another input, and here's another input. Like, okay, this one here is a PIR sensor. I've talked about these in class. Passive infrared sensor. This being a pretty clever passive infrared sensor, because it will actually work at a fairly low voltage. Standard PIR sensors that look like this, they're designed to work at slightly higher voltage, and our system here only works at 3.3 volts, So this is a 2.7, this will go down to, so this will work fine. So that's a PIR sensor. It's going to sense changes in the infrared heat signature around it, or the light spectrum around it, and you can use that as an input on your device if you wanted to. I've got a few of those in the cupboard you can have a mess around with. Okay, so that's obviously an output, the motor, the impact motor, but this is an input, the ultrasonic rangefinder, and this is an input, which is the PIR sensor, and of course my pressure mat sensor was an input, this one here. Okay, let's have a look at some outputs in more detail. So here is a ring of zip LEDs. Now these zip LEDs are individually addressable. That's where they get the zip name from, because the zip code in America is your postcode. Individually addressable, so you can talk to each individual one of these LEDs. So for example, if you wanted them all to turn orange, that's fine. But if you wanted an orange one to chase around to the left or to the right, or maybe a rainbow colour to spread over the ring of LEDs, then that is doable within the program. Just got your head around how to change the values and the numbers as it goes around. Have a search on the lessons part of the make code site. So here we go. This is another one now, zip LEDs, but in a strip with 1, 2, 3, 4, 5 zip LEDs that can be controlled as well. And in my room, you'll probably see the flexible strip of zip LEDs that you can cut and use singly if you want to. So that's very clever. I love these zip LEDs, but they're not mega bright. Okay, so don't go thinking you're going to get a super bright light off them. You're not. You'll probably be a bit disappointed. Okay, before I unbox the version 2, then let's have a look at how we can connect things onto the Microbit, because I've got a better system than this one, all right? Okay, so here we go. What we're going to use is my patent. They're not really patent, but they are. Maybe I should make some money. These are little plugs I've designed, okay? Now, they're designed so they sort of stack together, very slightly tapered. In other words, they get thinner towards the front end, and the hole in them, like I say, is also tapered, so they stack together if you want to keep them safe somewhere. Right, they're designed to be exactly the right size that when you pop them into the holes in the Microbit board, they wedge and stay in place like that. Okay, so look what you're going to do. If you want to make a connection into the Microbit board, you strip the end of the wire. Best way to do it is to use the wire strippers. Just close them up, put them in from the left to the right, and pull. And you'll see that what that does is it strips the wire. Now this is multi-core wire. You can see that's got several strands inside it. I would say that's probably the better kind of wire to use if you're making a connection to the Microbit. This one is a single core wire, and single core wire is a little tiny bit thicker. But I'll show you it will work with both kinds, right? So what you're going to do, let's say I wanted to connect this red wire onto the plus 3V, the power rail on the Microbit. So put that through the hole so that the bare metal is touching the edge of the hole. Okay, so oops daisy, put that up again. So the bare metal is in the hole. So bare metal to the hole, and then get your plug and push your plug into the hole as well. And what it should do is just force the metal against the side of the hole. Now make sure that the metal is not touching against any other tracks or pads on the back of the board. Now you can put as many of those as you like, right? I've tried it where you can stack up to sort of 3 or 4 on the same hole, and it does work quite well. So this is my system, right? You can find that you'll probably be able to fill up these. You'll probably have something on the plus or the minus. You might have one of the outputs being used, but you can certainly get to the main channels on the board using this sort of plug system, right? So these are in a little pot on the table by my whiteboard. Lots of different colours in there. You just need to grab them if you need to use them to fix things to the board. Okay, let's get to the main event, which is actually the unboxing of the version 2 board, and let's see what it can do. So here it is. Exciting times. If I had a trumpet, I'd be playing it right now. So it comes with the manual, tells you the things that it can do. All right, well worth a read. When I get my glasses on. The type is tiny, multiple languages. The board itself is in an anti-static bag, which means that it's protected in transit. I get a nice cable. Okay, so this cable now on the version 2 is USB-C they've gone over to now, okay? Oh no, it's not, sorry, it's still micro USB. Okay, and the cable's a little bit longer than normal, so USB to micro USB. You get a 3-volt battery pack with what's called a JST connector on the end of it, and you get 2 AAA batteries, brand new, so they're good to use. What's this then? This is some kind of case for the, what's that go for? Battery pack, if you're not using the plastic one maybe. And you get a free sticker. Oh my goodness, where am I going to put that? On my laptop, I think. Right, so let's put the box and the instructions to one side and let's have a close look at the board. So here it is. Now, look, exactly the same size as the standard Microbit, exactly the same size. So what are the differences? Well, apparently they've boosted the range of the low energy Bluetooth, so it works over a bigger area. So the thing in the corner there, that's your Bluetooth antenna. That's by here. Not really Internet of Things compatible just yet, but getting there probably, right? Same number of channels. Okay, so if I turn the board over a minute, you'll see they're numbered in exactly the same way. So this is the old board, this is the new board. You've got big pad on channel 0, big pad on channel 0, 1, 1, 2, 2, 3, sorry, 3 volt, 3 volt, so exactly the same there, right? And you've got button B, button B, button A, exactly the same. They've cleverly built the logo into a button, so that if you press the logo, you can use that as an input. Same LED matrix, okay, so you go 1, 2, 3, 4, 5 by 5, 25 RGB, sorry, are they RGB? I think they are actually, full colour LEDs. They've gone there, that's pretty neat. Now on the other side of it, we've got more changes probably, right? So on here, you've got a built-in microphone and you've got a built-in loudspeaker, so you can actually make it play tunes. Only monophonic though, okay? You don't go thinking you can play MP3s and stuff through it. So this one then you can sense sound with. So if you clap to this one, you can pick up a vibration from it. And the other sensors that it's got in are pretty similar, okay? So all the standard ones that this has got, so you've got accelerometer, so it can measure tilt like this in both directions. It can measure tilt in this direction. It can measure force compared to gravity, so whether 2 times G, 3 times G, 4 times G, it can do that for you. It's got a built-in temperature sensor on board, and it's also got a clever way of using the LEDs to use it as a light sensor. So all those things are packed into the board already. So that's pretty clever, isn't it? As a device goes, it's well worth investigating. Now these little notches that come out the board here, I'm not 100% sure what they're for, so I'll have to find out about that. But I'm going to try a bit of programming, I think, and see about experimenting with the new inputs. When you get onto the Microbit coding platform, you'll see that some of the code commands will say only for V2. Now the good news is that the IT department has got a class set of these V2 microbits that are there for you to have to mess around with. So if you do get into it and you want to try and develop further, then that's probably a good idea to have a word with a member of the IT department and see whether you can get your hands on one of those to have a play around with it. Okay, so yeah, here we go. My next job, I guess, well, you've seen this in school, I think, probably. I've got my PIR sensor. I'm going to strip the LED from my old-fashioned screws, my connectors, and here's this one here, and I'm going to put those on one of my outputs, so that what the negative of these will go onto the minus, and my channel for the output will probably be 0, and I'm going to have a mess around with it. But on this board, I have a system where I can clap and turn it on and turn it off, or maybe play around with the PIR a little bit more. Alright, so there's a lot to think about with this project, and you really do need to be thinking, what do I want my light to do, and then how will I accomplish that, okay? Some of your ideas may be complicated. We might not be able to do them in as much detail as you're envisaging, but we'll have a good go at experimenting with some really complicated, well, some really complex and cool components, all right? Well done for listening. You might want to pause and rewind and then go over some of the stuff that I've gone over, just to pick out some key terms that you can use in your annotations for your design sketches.